In this example, we're going to use the remainder of the alternating series to estimate a sum to within a certain error tolerance. So the first thing we're asked is to show that this alternating series, -1 to the n times e to the negative n, is convergent, and then asks how many terms that we need to add in order to get the sum to be within 0.01 of its actual value. All right, so we notice that this is really an alternating series. Here's your alternating part, and these pieces are all positive. We need to show that it's decreasing and has a limit of 0. Again, probably the easiest way to show that this one is decreasing is to take a derivative, use a product rule here, and notice that we can factor out an e to the negative x. So when we pull out an e to the negative x, we get a times a 1 minus x here. E to the negative x is always positive, no matter what we plug in for x. And certainly once x gets bigger than 1, the derivative will be negative. So our original, or the terms that we're talking about, the non-alternating part, is always positive and is decreasing. Now again, if we want to show that this limit is equal to 0, L'Hopital's rule is probably the easiest way to go. Make a fraction out of it. Certainly we've got infinity over infinity now. Derivative of the top is 1. Derivative of the bottom is still e to the x. That limit's going to go to 0 because e to the x is going to get large as x gets large. So we really do have a converging alternating series here by the alternating series test. Okay, so now we want to estimate the series to within an error, to within an accuracy of 0.01, the error to be less than 0.01, which means that we want the absolute value of the remainder to be less than 0.01. Remember that the absolute value of the remainder is bounded by the first term we leave off. So we need the first term that we leave off to be less than 0.01. So we need to make sure that our terms of the sequence here, which look like n e to the negative n, are less than 0.01. Really, we probably should have an n plus 1 here, but it's a little bit easier to analyze this thing to get this to be less than 0.01. And remember, this is the n plus first term that we're really talking about here. We know that the terms are always decreasing. So basically, we can just start plugging in numbers one at a time until we get to the point where we get to less than 0.01. So we put in n equal to 6, we're still a little bit bigger, but if we put in n equal to 7, we get less. So our n plus first term, that is less than 0.001, is the 7th, which means the n that we need is 6. So this means that we need to add 6 terms together to guarantee that the sum of the series is within, the sum that we get is within 0.01 of the true value of the series.